So once we understand the concept of using function notation, we can then move on to do some calculations. Here in example number 2, I have created a few functions here. And I'm going to create a different function tomorrow. Now, for today, at this moment, I have a function f that can be calculated using this equation here. 3x squared minus 4x plus 1. I have this one equation for function f. And then I have function g, function h, function k. These are all randomly created. I can change them to something else. Depends on my mood. It doesn't matter. Like on your test, you probably will end up with a different function called f. But for now, in this example, let's say I have function f, g, h, and k here. Find the following. And for the first one, we are working with function g. But instead of working with function g that is in terms of x, they replaced the x inside the bracket with a 2. The question has g of 2 instead of g of x. From the question itself, here is function g, 3x minus 1. But now if they want us to use 2 instead of x, that means we will replace the x in this equation with a 2. So in this case, we will end up with 3 times 2. Instead of working with x, we will now replace it with 2. So 6 minus 1 equals 5. And that will give us the output of the function when you are using the input in this case. If you're using x equals 2 as an input, this function will give us the output 5. You can substitute numbers, replace your x with a number. You can also replace your x with something else. And then I'll go back to part B in just a minute. But let's say in this case, in part C, example 2C, if they want us to work with function f, let me copy this from the above. We know, for now we know f of x equals 3x squared minus 4x plus 1. But the question wants us to use 2x instead of x. So now, as they replace the x with 2x, we will now replace the x here with 2x. And we will replace the x here with 2x again. And everything will get simplified to something like this. So as you can see, we can substitute number, replace the x with a number, like in this case. We can also replace the x with 2x or with something else. It really depends on the question itself. They may want us next time, they may want us to replace the x with x minus 5. Or they may want us to replace the x with another variable. You simply replace everything in your equation with whatever is given and put it at the same place.
But how do we put this into the graph?
Alright, back to part B. when you look at the questions, yes, we know what it means. They want us to work with function k. And function k involves these three terms here. But in front of it, they have a 4. What does it really mean when there is a number in front of something? Times, yes. That simply means we have 4 times something. Oops, this is function k. And that means we will multiply the entire function k by positive 4. Use your distributive property, and that's all you need. Now, it is also possible to work with two functions at the same time. And then they want us to add the two functions together at the end. So, for part D, they want us to work with function h. Function h equals the square root of x minus 4. But now, we don't have x minus 4. They want us to replace the x here with 13. And in this equation, we will now replace the x with 13. So for this part, we have square root of 9 at the end, which equals 3. We are going to have 3 plus 2 times the function g. So once again, here let me reorganize all my work. Starting with function h, we have h of x equals square root of x minus 4. But as they want us to use 13 instead of x, we will have 13 minus 4 instead, giving us square root of 9. For the second half, they want us to work with function g. Well, let me ignore the 2 for now. We're going to add it back to the equation. But for now, at the beginning, starting with function g, this time they want us to use x equals 3. So in this equation, we will replace the x here with positive 3. So 3 times 3 minus 1 will give us 8. Yeah, so what about the 2? We are going to bring everything together. So now, starting at the beginning, here is 3 plus, we are going to add 2 times of function g, which is here. So bring them all together, we will have positive 19. And finally, if we are to work with function k, function g, and have something else instead of just number, let's say they want us to use x minus 4 instead for function g, we are going to make all those substitution. So at the beginning, we will multiply function k by 2. This part is function k, and we have it. We will times it by 2, and then for function g, instead of working with 3x minus 1, they want us to use x minus 4 instead. And that means I will now replace the x here with x minus 4. This will be the second part from here. 3x minus 4, well, 3 times x minus 4 minus 1. So now, expand it. This is from part 1. And then here, this is from part 2. So as you can see, I'm trying to deal with this one at a time. I'll try to expand it for now. And for this part, I turn it into those 3 terms at this moment. And we can then bring all the like terms together. 2x squared at the beginning will still be there. Minus 4x minus 3x minus 7x minus 7. We have plus 6 minus negative 13. Be careful with your sign. You actually will end up with plus 19 in this case, because positive 6 minus negative 13 will turn into plus 13. So that will give us plus 19 at the end.